This is part 2 of our circles series. This is going to be going over tangent properties. The first thing we want to do is review a couple of terms. Remember that a tangent is a straight line that touches a circle at exactly one point. You can see here in this picture, when you have the circle, the line is outside the circle and it just kind of grazes the edge at one point. Okay, so to name the tangent, you use 2 points, any 2 points on the circle. So here, most of you would call this AB, and you don't want to forget your symbol for a line above it. Remember, when naming a line, the order of the letters does not matter, so you could also say BA. And there are no endpoints to a line. Those arrows indicate that it goes on forever, so you could even use C. So you could say AC, CA, CB, or BC. So there are several correct ways to name that line. The point of tangency is the point where the line grazes the circle. So in this case, that is point C. Okay, there is no symbol that goes above a point. You just use the capital letter to name it. So that's point C. Okay, the first conjecture you'll want to remember is that a tangent to a circle is perpendicular to the radius drawn at the point of tangency. Okay, so here in our blank it would be is perpendicular to. Remember, this is the symbol for perpendicular. If you need to write it out, you can. Okay, so the tangent, this pink line, is perpendicular to the radius drawn. And hopefully everybody remembers that perpendicular means it creates a 90-degree angle. So we have a 90-degree angle here. Again, you may need to write that down if you don't remember. That's 90 degrees. If you have 2 tangents outside a circle that meet at a point outside the circle, okay, the tangent segments to a circle from a point outside the circle are equal or congruent. They are the same distance from the circle. So here, the distance from A to B is the same as from C to B. We're going to go over just a couple of examples now that you've got those properties written down using some of those rules. Okay, in this example, you're asked to find this missing length. Now, with no markings, you have to remember that a tangent and a radius are perpendicular. So this is a 90-degree angle. So this triangle that is now created is a right triangle, and you can use Pythagorean theorem to solve for the missing side. Okay, the missing side is the hypotenuse. It's across from the 90, so that would be your C. So 8 squared plus 15 squared equals C squared. And again, if you remember your Pythagorean triples, this can save you some time. And remember that there is a 8, 15, 17. So you can actually work this out, squaring, adding, and then taking the square root, or you can remember your triple, which means that that side is 17 units long. Okay, in this one, you have 2 tangents that meet at the same point outside the circle. So I know that these are congruent. I will go ahead and mark that. I also have a radius drawn to each point of tangency. So from this point of tangency to the center is a radius, and from this point of tangency to the center is a radius. Those must be equal because they're both a radius of the same circle. Okay, so if you remember your properties of polygons, this is a kite. Okay, and any quadrilateral, it doesn't really matter that it's a kite, any quadrilateral adds up to 360 degrees. And I know that my radius and my tangent make a 90-degree angle, so this total is 90 degrees. Okay, and they've told me here that this piece is 31, and since these are equal, this piece would also be 31. So I can go ahead and look at this portion of my kite, this triangle created, and find the central angle, and then I would know 3 angles of my quadrilateral that I could add and subtract from 360. So first I'm looking at just the triangle. 31 and 31 is 62. subtracted from 180 is 118. Now you know that that is the central angle, and the quadrilateral we know that adds up to 360. So I'm going to add the 118 and the 90 and 90 to get 298. So from these three angles here, I've used 298 of my 360. So then I take 360 minus 298. And I get 62 degrees. So this missing angle is 62 degrees. Let's try one other example. Now this, I don't believe we went over when we talked about the vocab, but when you have a circle inside of a quadrilateral, where every side of the quadrilateral is a tangent to the circle, this is called an inscribed. This circle is inscribed in the quadrilateral. Okay, and when you have that, remember that each tangent here to here is going to be the same length. Here and here will be the same. These will be the same. And those will be the same. So what I'm going to do is use that I know this entire length is 14.6, and since this is 10, this is also 10. So when I subtract that, I get 4.6, which will be the same here, which subtracted from 12 would be 7.4, which is congruent to this side. And since this is 5.7, this would be as well. So now I know every missing piece of that quadrilateral broken down by in between all of the points of tangency. Okay, so those are how you would use your tangent properties to solve problems with circles.